This week I am summarizing chapter 13, the study of technology-based inquiry learning, automatic analysis of online personal feedback processes. In this chapter, they talked about a study they did that examined how technology-based learning environments using the Seeing the Entire Picture or STEP platform can support mathematical inquiry through the use of automated personalized feedback. Students engaged in inquiry tasks that required them to explore patterns, generate conjectures, and refine their thinking over time. They use example eliciting tasks, which are tasks where students construct several examples for a given mathematical situation. The construction of examples helps students develop mathematical ideas. It expands their personal example space and conceptual understanding. The personal example space is a collection of examples that students generate in response to specific tasks within certain contexts, and it can serve as a tool for explaining to students mathematical reasoning. The STEP platform captured students' responses in real time and provided feedback that went beyond corrections. It highlighted patterns, inconsistencies, and offered next steps. Personal feedback played two roles in this study: verification or the correctness of answers, and elaboration or the explanation of why a response is correct or incorrect. The personal reports that students received from the STEP platform were used to spark inner dialogue amongst themselves, allowing them to reflect on their own understanding, progress, and gave them insights into their learning journey. The researchers found that feedback was most effective when students actively engaged with it. They were able to revise their ideas, test new conjectures, and deepen their reasoning. In that way, feedback functioned as an ongoing part of the learning process that supported persistence and sense making. The goal of the chapter was to show the process of tracking and analyzing students' inquiry processes, specifically their work on the example eliciting task with the support of elaborated feedback. They focus on two key parameters: meeting task requirements and the diversity of their examples. Feedback was provided to students and about critical and non-critical characteristics of the task they submitted. The STEP platform organized the information and helped to analyze student examples. Two insights that they took away from this was about the design of the study, to maintain the uniform language in the feedback and make sure that the language aligned to the language of the task. And then students had a preference about what they expected to see in their report. And so from that, the information provided helped students to meet the requirements effectively and then fostered engagement with the elaborated feedback. So ultimately, this was just about how technology-based inquiry learning was most effective when automated feedback was intentionally designed to engage students in the process of thinking and not just giving them correct or incorrect feedback. The study shows that feedback has the greatest impact when it pushes students to analyze their own thinking, test assumptions, and distinguish between critical and non-critical characteristics of a mathematical idea. In those moments, feedback becomes a tool for reasoning, and it helps students to refine and generalize their thinking over time.